Okay, before we begin soldering, let's talk a little bit about the equipment that we're going to use. And first off, let's talk about the solder. The solder you use for surface mount, generally the pins are smaller, so you don't use the solder like this, which is generally for large through-hole components. You use a solder like this. It's about half the diameter, a quarter of the size. It enables you to feed out the solder onto the pad at a much slower rate, and enables you to not overdo it. You can get it down at the right speed. The other thing that you need when you're doing surface mount is you need a good set of tweezers. And by tweezers I mean they come together. Even these ones here, I'm looking at them, they don't really come together at a fine point. They should come together at the end. They should come together well. If I turn them on their side here, you can see that these tweezers, the ends come together at the same point. You cannot do surface mount stuff with chopsticks. It's not going to work. So large tweezers that the ends don't come together, all you're going to do is flip the part around and spin it on yourself. Okay, so to start off, I'm going to put down 6 components here. So what I'm going to do is I'm going to go and put down a little bit of solder on one leg, and I'm going to put down enough just to hold the part down. So I'm not putting down the final amount of solder. I'm going to try and put down about half the solder. So I'm going to put a little bit there, a little bit there. I'm putting down as little as I can, more or less here. And usually when I'm doing a whole bunch of parts, I will go down and I will do one leg first, and I will do one leg on all the parts, getting everything ready. Then I can go in with my tweezers. I can pick the part up and I place it on the pad that was soldered, and I reflow the solder on it, and now it's soldered on with the one pad on this side. Again, it's not the final amount of solder. It's probably a little bit shy of the final amount of solder, but it's enough to hold the part in place while I work around the rest of the board. And there you can see I sort of jiggled as I was letting that one cool off. So this solder joint has probably got some fractures on it. It's probably got a little bit of a gray color. This one here, and that's pretty common, that if you look at sometimes people's solder joints, they present it to you at the end, and you can look and you say, you did the pad on the right first, and then you didn't go back and touch it up again. And they say, well, yeah, how'd you know that? Because they're all gray, because the first one, as you wiggle around, usually ends up being not as good as the second one. So now I'm picking these guys up, placing them down, like so. Doesn't matter which fat pad you start with. And flipped it over upside down, so I'm just trying to pick it up and drop it, trying to get it to flip right side up again. Oh, there we go. So there. Come on. Put it down when it's not 100% centered. And you have to make sure that the first leg you put down, the component is actually down flat on the circuit board. So I'm going to press down on this one here and reflow that joint. Because if it's not flat, then you know what, when you solder the other 2 or 3 legs, it's still not going to be flat. So it's important to get it flat on the first component. Now that I've done one side, I'm going to come in on the other side. I did the one on the right, on my right, so now I'm going to do the one on the left. Do that joint, and a little bit more. You can see that with this small solder here, I'm actually able to control pretty accurately how much solder goes into the joint and keep the fillet nice. I can do this one, which you can't see, like so. Now take a note that what I'm trying to do with this soldering is I'm trying to touch the pad and the pin and heat it up, and then I bring in the solder right about there, and it reflows and solders the two together. This stops if you put solder on the soldering iron tip. I find that when you go do this, sometimes it wants to jump onto the pin only, and you don't get any on the joint. If I do this and I heat them both up, come in, you can see that both of those guys, that's a good solder joint. Now I've done one side. I need to go back and touch up or finish off my first solder joint. So add a little bit to that side, a little bit there, a little bit there, a little bit there, then again on these here, just sort of fill in the remainder that it needs. That one looks good there. Okay, so there's some SOT23s, some MELF diodes, and some 1206 resistors. Removing components. In order to get components off the board, you must heat up all of the pins at the same time. If you have even one pin sticking even just a little, if you give it a little bit too much pressure, all it's going to do is tear your pad off the board. Now, the quickest way to do this, it's not the best, because you can still rip pads off if you apply too much pressure, is basically to go in and hit one side of the part you want to take off and hold it there for a while, and then just rock over to the other side and very quickly flick it off. So get one side liquid, go to the other side, and it should flick off. You should not do what I just did there, because what that does is it splatters solder all over your board, leaving it in places that you don't want it. So I would not do that on a real circuit board. So one side, then the other. One side, then the other. Okay, now these guys here, the SOT23s, they've got 3 pins, and it doesn't look like I can actually get, if I tried to go 1, 2, 3, by the time I got to the third one, the first one might be cooled down too much to release. So I tend to go in on those guys. You go in and you get these 2 at the same time, put the iron across them, and jump over to the other side, off it comes. And we'll get this one here, so I'm sort of put my iron on this guy, slide it over. I got both of those. Oh, no, not good enough. Pick something else up. Okay, so here we go. Now you see what I'm doing here. This is not great, because I could tear that pad off. If it hasn't cooled and I'm wiggling the other end, you could tear that pad right off. I've managed to get away lucky on this one. So now all the parts have been removed. Before you can put another part down, you must remove all the solder off the pad, or the next part you put down will not sit down properly on the pad, and you won't be able to center it. It'll be much more difficult to center. So get a little bit of solder braid, heat it up, and when the solder is liquid, move the solder around on the pad. But when it's liquid, because if it's not liquid, you're just putting too much pressure on the pad. Whoop! See, there's one that had a little bit too much force applied to it, and I've taken it off. These pads, really all they are is they're glued down onto the circuit board, so you can very easily, if you put too much heat on them, you will unglue a pad. So the smaller the pad, the more likely you are to unglue it. Speed is important on these soldering operations. Get in, get out. Do not spend a lot of time dicking around trying to get some joint that doesn't want to go. Put a little bit more flux on. If it doesn't look like it's heating up properly, then you need to start putting on flux. The little solder that we have has flux embedded in it, and you can see that when I touch the iron here. You can see a little bit of smoke coming out of it. That is not well, that's flux. So there's flux in this thing if it's steaming like that. You can see even that guy there. I've ruined that pad. Too much time spent on the pad. Even here, it's sticking, but you can see it's wiggling there. It's let's go. So you only have 1 to 2 seconds of soldering time before you start peeling pads off. If it's a pad like this where there's no lead coming into it, it's worse because the heat can't travel down the lead. If it's got a piece of copper trace on it, it's actually a little bit better because some of the heat will go down the trace and keep the pad a little bit cooler. No trace, basically it just all sits there and acts on the glue or on the circuit board holding it on, and it just kills it. Okay, SOICs are small outline integrated circuits. How do we deal with those? Well, you want to start off by putting a little bit of solder down on a single pad. So I'll put a little bit of solder down on pad 1 there. And again, just enough to hold the part in place while you do the rest of the pads. So then I come in with my component and I place my component. Now, because the pad that you just soldered is actually a little bit of a hill, it's going to be a little bit tricky sometimes to get the part to sit on the pad. I got the microscope here, so I'm looking at it from above. I can see pretty good that I've got that fairly well centered. Now, the techniques shown in the other guy's video that I showed you, they're not bad, but the reality is probably the most success that I've had with soldering these guys or anything is just to do it just the normal way. Come in and touch the pad. I'm going to have to do one on, if it budges a little bit, you can recenter it. I'm going to have to do this one on your blind side first. Okay, so there's that one. They suggest that you put a little bit of solder on the iron and then try and tap it in. I haven't found that that works that well. I find that proper soldering, the same way as you do a through hole, the pitch on this stuff really isn't that bad. So you come in, I'm heating up the pad and the footprint. There's a little bit of solder there. Come in here, solder. Come in here, solder. So I put the tip on one side, I heat up both, and when they're hot, I put a little bit of solder in. Then I'm going to go back and make sure that my first pin has enough solder on it. That should be a good solder joint. Now, a good solder joint, when you look at it, let me just overdo it here. This is not a good solder joint where there's a big mound of solder on top of the pin. When you're looking down on the part, you should still see the square outline of the pin on top of the pad, and then you should see some nice curved fillets down to the circuit board. So I'll do this side, this side, this side, this side. That last one wanted to go on the pin. Okay, so there's putting them on. Let's go to the next video where we'll talk about taking off SOICs. You can use the braid and you can try and remove solder from underneath the parts. However, solder that's gone in between the pad and the pin is pretty much impossible to get out. And if there's one pin on here that's sticking, that part just does not want to come off the board. So what I have found is that with just the regular solder, now here I'm going to use a little thicker solder because there's more of it. So if I just come in with the regular solder and I put a bunch on both sides, if I do this, go back and forth reasonably well, I should be able to, if I get all the pins on one side liquid, I'm prying this part up a little bit. Come on. There, I'm lifting it off. You can see that I'm lifting it off. Once it's up, then I can go in with my braid, make sure that all the pins are disconnected from the board. Looks like we're stuck a little bit down on this side. So now that's floating. Now we go in on the other side, do the same thing. Oh, terrible job. Ripped off half the pins. Okay, so now I'm going to remove an SOIC using a proper hot air gun. So this is a tiny little hot air gun that comes on the soldering tip.
Is this supposed to be protected?
And it blows hot air out onto this SOIC.
I thought that they sucked.
It does both. keep moving around the chip.
How hot's the air?
Probably 650 degrees C. Well, finally, chip comes right off. Okay, desoldering larger ICs. Multiple pins. Gets a little bit harder to heat up all the pins with a soldering iron at the same time and getting them so that you can take them off. So generally with the larger stuff, it's a little bit safer to do it with something like a heat gun. Now I'm going to do this chip here in the middle, and I'm just going to do it here. You can see I've got like a cheap Mastercraft heat gun. This is probably not the right tool, but it does work as long as you keep the heat down. This will strip paint and start fires on things, so it's pretty hot, probably hotter than you want, but it will do the job. So essentially, turn it on to the high setting. Get the thing a couple inches away. I'm actually using the camera there, but it's probably about 2 or 3 inches away. And just come in with your tweezers every couple of seconds or so. Just try and give it a little bit of a nudge and see if it moves. See the flux starting to bubble on one side. Things get pretty hot. Still solid. Now I think the flux of solder is getting liquid. There's lifting. So that's about all there is to it. So now you'd go in and clean up those pins. I'm not sure if I lost one or if it was lost before, but if you don't get everything heated up, then you can lose. There's a pad missing here and a pad missing there. So you got to make sure you don't lift too soon, that it's all liquid, because with the heat gun going, the pad bonding to the circuit board is reduced, and if you lift it and there's one sticking, you'll just rip the pad right off.